Good day, everyone. Welcome to quarter one, week 5 of general mathematics. So for our first lesson, this is all about real life problems involving inverse functions. Actually, this is the last topic of what we had last week, which is all about inverse functions. So to discuss more of this, let me present to you first the objectives. First, we need to recall how to find the inverse of the functions. Second, solve problems involving inverse functions. Third, evaluate inverse functions and interpret results. So basically, for us to recall the different steps, I have here an activity in which you need to know the tallest building in the world, okay, by getting, of course, the inverse of each given function. So like for this one, g of x is equal to x to the fifth minus 3. If you will solve this following the steps on how to get the inverse of a function, you'll probably get the same answer as mine, which is letter B. Okay? So actually, if you will continue practicing on how to get the inverse of a given function, you will see that, like for this example, given x to the fifth, since the exponent is 5, you need to think of its inverse. And the inverse of 5, of course, is 1 over 5. And if you will transform that into symbols, 1 over 5 or 1/5 is actually the same as getting the fifth root of something. So with those in column B, the one with the fifth root is just letter B. And then, of course, you need to get the inverse sign of your constant. So from here, from the original, it's -3. So its inverse is +3. That's why the answer is letter B. Then for number 2, if in case your x or your variable x has a numerical coefficient, okay, not an exponent anymore, just in the case of number 1. So if you have a numerical coefficient of x, to get the inverse of that, you need to put that in the denominator. So since we have here the 7, so look for the inverse function with a denominator of 7. And that will be either r or u. Okay? But of course, the r has a cube root. So it's x already, not in our option. So obviously, it will be letter u. Okay, and then as I have explained to you with example number 1, for all the constants, you need to get the inverse sign of that. So since this is +10, then you'll have -10. Okay, even without solving, huh? Okay, third, in the case of a rational function given, to get its inverse, all you need to do is to, how do you call that? Cross exchange, actually, the constant of your denominator and the numerical coefficient of your numerator. So look at this one. Since the numerical coefficient of x is 4, so you will place the 4 without changing the sign in the denominator. So you will have 9x minus 4 in the denominator, and in your numerator, you will have 5x plus 1 for its inverse, and that will be letter R. Okay. Next, in the case of number 4, okay, you need to inverse the fraction. Okay, inversing 5 over 9, it will be 9 over 5. And then for the constants, -32 and +32, inverse them in position. So it will be k minus 273.15, which is yung letter J natin. Okay, so completing the answer in these exercises, then you will get the tallest building in the world is the Burj Khalifa, which can be found in the United Arab Emirates. Okay. Yan. So it's for you to explore how to get easily the inverse of the functions given in 6 to 11. Okay. So as we continue to recall the different steps in finding the inverse of a function, first you need to replace f of x with y, then interchange the x and y variables. Then you need to solve for the value of y from the new equation obtained in step number 2. And lastly, replace y by f of -1 of x just to indicate that that is already the inverse of the given function. So those are the steps. Now let us take a look on this example. This is actually an example on the inverse function. Okay, so the SSG officers of Quezon National High School are planning for a JS prom. So assuming that there is a JS prom, okay, the allocated budget for decoration, sounds, and other miscellaneous expenses is 10,000 pesos and an additional 150 pesos for meal expenses for each guest. The organization received an amount of 40,000 pesos from its stakeholders. Okay, so from the first case, we have there the 10,000 pesos as the miscellaneous expenses, and then it will have an additional expenses for the meal of the guest, which is 150 for each guest. Okay, so for letter A, we need to write the total allocated budget as a function of the number of guests. So meaning we have to transform this problem into a function. Okay. Then letter B, find the inverse of the function. Letter C, state the domain and the range. And lastly, we need to find the possible number of guests if we have a budget of 40,000 as is stated on the last, okay, on the last sentence. So to solve for that, we have to let X be the number of guests. Okay, so to solve for letter A, we need to assume that X be the number of guests since we do not know yet, or we don't have an exact number of guests. So we let X be that number. And then of course, f of X be the allocated budget as a function of the number of guests. So therefore, for us to solve for the allocated budget, then it will be f of X is equal to 10,000. Okay, that's the first budget, plus the 150,000, the 150 pesos, which is the additional one, times the number of guests. Okay, so this one is the function for the representation of the problem in terms of function. And to find its inverse, so just like I have mentioned to you, since the numerical coefficient of X is 150, so we'll put that in the denominator and getting the inverse sign of the constant, which is negative 10,000. So as a whole, the inverse of this function, which is a one-to-one, of course, is f of negative 1 of X is equal to X minus 10,000 over 150. And for letter C, use the inverse function to find the domain in the range. So since we have there the given value of X, which is the allotted budget, okay, so from the inverse function itself, we need to find its inverse. So X here is the 40,000. So solving for the value of f of negative 1 when X is equal to when X is equal to 40,000, then it will be 200. Okay, so that will be our domain. Okay. And then the range, of course, will be the 40,000. But look at the notation. Why is it that our X must be an element of the set of natural numbers? Because, of course, it's impossible for us to have a negative number of guests, right? And so that's why the limitation of X here, it should be greater than or equal to 0, but less than or equal to 200. Okay. Then obviously, the maximum budget is 40,000. Okay. So in letter D, so we said that therefore for a budget of 40,000, 200 students may attend the JS prom. If there are more than 200 students, then the organization needs to think of other means to raise additional funds for the prom, because the budget will be more than 40,000 if there will be more than 200 students. Okay, so that's how we interpret results of an inverse function. Let's have the second lesson for this week, which is the first topic for exponential functions. So we're done with inverse functions. The next function to discuss and until next week is all about exponential functions. So representing real life situations using exponential functions. So ano ba itong exponential functions that we are talking? So these are the objectives: define exponential functions, show illustrations of exponential functions that represent real life situations, represent real life situations using exponential functions, and solve problems involving real life situations using exponential functions. Okay, first I will give you the definition of what an exponential function is. So basically, when we say exponential function, it is a function of the form f of x. So with our notation for the function, it's either f of x or y, which is equal to b raised to x, or y equals b raised to x, where b should be greater than 0. So any number greater than 0 will be our base, and that b should not be equal to 1. Okay? Although it's greater than 0, although 1 is greater than 0, but it should not be the case, because when your base is 1, raised to whatever exponent, of course, the value of that will still be equal to 1. Okay? And so, based with our definition, how are you going to classify the given functions? Which do you think of the 6 are examples of exponential functions? Can you think of it? Can you think of those examples from the given 6 functions? Okay, so that is right. F of x equals 6 raised to x is an example of an exponential function. Same with f of x equals 6 of x equals 3 raised to x plus 1. And the last one, okay. So 1 raised to x is not an example, although the base is a constant. But then again, with our limitation, 1 should not be the value of our y, of our b rather. Okay, so these are the only 3 examples of exponential functions. Okay, so we have here examples on how to evaluate an exponential function. So given the values of x, which are -3, -2, -1, 0, 1, 2, and 3, for the exponential functions, y equals 1/3 raised to x, y equals 10 raised to x, and y equals 0.8 raised to x. Okay, so actually we have here 3 exponential functions. And in each exponential function, we're going to substitute the 7 values of x in order for us to find the value of the given function. So let's have first the first exponential function, which is y equals 1/3 of x. Okay, so if we will first substitute the value of x, which is -3, then we will have, yan. So 1/3 or 1/3 raised to -3. Of course, we all know that we cannot evaluate expressions with a negative exponent. So we need to reverse the base and then changing the sign of the exponent. Then we have 3 raised to the 3rd power, and you know that 3 raised to the 3rd power is equal to 27. Okay, then we do the same when x is equal to -2, so that is equal to 9. When x is equal to -1, it's equal to 3. When x is equal to 0, of course, any value or any variable, any expression, any constant raised to a 0 exponent is always equal to 1. Then if it is raised to 1, it's the same value. When raised to the 2nd power, it's 1/9. And when raised to the 3rd power is 1/27. So these are the processes by which we can get the value of y given the values of x here. Okay, so let's have the table of values for the second exponential function. Okay, for the second exponential function, given y equals 10 raised to x, again, substitute the values of x, -3, -2, okay, -1, 0, 1, 2, and then lastly we have the 3. Okay, so these are the values of y given the values of x. Okay, so I hope you're familiar in doing that. Let's have the third exponential function, which is y equals 0.8 raised to the x power. Okay, so we first try to convert the decimal kasi why? Because when we have decimals, all we need to do is just an approximation, because there will be a case where the decimal will not only contain 1 decimal place, but instead there are cases that it will have 5 or more or whatsoever. So it will be difficult for us to deal with such kind of decimal numbers. So that's why we tried to convert 0.8 to fraction. So it's 8/10. And then the lowest term, of course, is the 4/5. And then the same thing, we cannot evaluate an expression with a negative exponent. So we need to reverse 4/5. And then that's the only time for us to get the value of that raised to the third power. So it's 125 over 64. If it is raised to negative 2, it's 25 over 16. If it is raised to negative 1, it's 5 over 4. If it is raised to 0, that's equal to 1. If it is raised to 1, of course, it's 4 over 5. Raised to the second power, it's 16 over 25. And lastly, raised to the third power is 64 over 125. So these are the ways by which we can get the value of a given exponential functions. Okay, so these are some real life examples by which we can apply exponential functions. Okay, so we have the population growth, the exponential decay, which is just the opposite of population growth, and then the compound interest. Okay, let's have one problem. Okay, so suppose a quantity y doubles every t units of time. So since it doubles, meaning its population growth. Okay, so if y sub 0 is the initial amount, then the quantity y after t units is given by y equals y sub 0 times 2 raised to t over t. Okay, so that's the basic formula for population growth. Okay, so usually this is very useful when we have bacteria problem. Okay, that's why it's an exponential problem. Okay, so as you can see, we let t be the time in days. Then from the start, when t is equal to 0, there will initially be, of course, 20 bacteria. Okay, so suppose that the bacteria double every 100 hours. Okay, given an exponential model for the bacteria, give an exponential model. Okay, so we know that if t is equal to 0, which is the number of bacteria is 20, then we have, okay, at t, which is 100, then we will have 20 times 2, okay, double. Then at t equals 200, then it will be 20 times 2 raised to the second power. Okay, double. Okay. Okay, until such time, okay, that the t is being doubled. Okay, so generally an exponential model for this kind of situation, given the initial number of bacteria, which is 20, so we have y equals 20 times 2 raised to t over 100. Okay, okay. Third lesson, how do we recognize exponential functions, exponential equations, and exponential inequalities? This is just somewhat similar in identifying a rational function, a rational equation, and a rational inequalities. Okay. So first objective, we need to distinguish which one is an exponential function, an exponential equation, or an exponential inequality. And then at the same time, we need to formulate our own examples of exponential functions, equations, and inequalities based on what we have understood from the first objective. Okay. And so to have an idea on how to distinguish an exponential function from an exponential equation and an exponential inequality, let's have first this activity, which is spot the similarity and difference. So I have here 3 expressions. So what do you think are their similarities and at the same time their differences? Okay, so as you can see here, they have a constant base, the 3, the 4, and the 2. And their exponents, of course, are all algebraic expressions. Okay, so trying to find the similarities of ABC, and examples ABC, examples A and C, okay, with A and C, and okay, they are both, they do not contain the Y, which is the symbol for a function, okay? And then for A and C, how does it differ from B? Of course, B, of course, has a variable Y. They have 2 variables here, the X and the Y, but with the case of A and C, it only contains, or they only contains the variable X. Then how are A and B similar to each other? Okay. And then lastly, how do A and B differ from C? So of course, you know now that B is called as the exponential function, A is the exponential equation, and C is the exponential inequality. So if there's only one variable from the given expression or equation, and then we have an equal sign, therefore it's an exponential equation. But if it contains inequality symbols like this one, then we have an exponential inequality. But if it contains two variables, we have exponential functions. Okay, so to give you the definition, so as we say, exponential function is a function involving exponential expression showing a relationship between the independent variable x and the dependent variable y. We have there the output and the input actually. In the case of exponential equation, it is an equation involving exponential expression that can be solved for all x values satisfying the equation. So it can be in one side only or on the two sides of the equation. Okay. And lastly, when we see exponential inequality, as I have said to you earlier, if it contains inequality symbols where we can solve for the value of x, then it becomes an exponential inequality. Okay, so for your learning task number 3, this is very easy. You need to just identify where each exponential expression belongs. Okay, so these are the expressions. We have 15 expressions, and then you need to put them in our table, whether they are under the exponential function, exponential equation, exponential inequality, or neither of the three for the none of this. Okay, so you need to show the complete table. The last topic, we need to solving exponential equations and inequalities. We come to the last lesson for this week, which is solving exponential equations and inequalities. We need to solve for the value of x. So these are the objectives. Identify the properties used in solving exponential equations and inequalities. I hope you are familiar with that. And then solve exponential equations and inequalities. Okay, so first for us to solve, we need to identify, or we need to have our eyes wide open on on how to classify expressions as two exponential equations or inequalities. So given these expressions, which of these do you think are examples of exponential equations? Okay, so you are right. The first one, correct. The third one, what else? Okay, letter D is also an example. Letter B is not an example because it does not contain a constant, which is the base, and an algebraic expression for its exponent. Okay, so which else? Okay, nothing more. Okay, so we only have 3 examples for exponential equations. So remember this, that in solving exponential equation, you need to remember the one-to-one property. And what is this one-to-one property? One-to-one property of exponential functions states that in f of x, which is equal to b raised to x, if x sub 1 is not equal to x sub 2, then b raised to x sub 1 is not equal to b raised to x sub 2. Conversely, if b raised to x sub 1 is equal to b raised to x sub 2, rather, okay, so sorry for the typographical error here, it should be b raised to x sub 2, then obviously x sub 1 is equal to x sub 2. Okay, let's try solving this one. Solve for x in 3 raised to x equals 3 raised to 2x minus 1, okay? So obviously, it's already in the one-to-one property. Okay, your b sub 1 and b sub 2 are equal. Okay, so it's one-to-one property na. So we can, how do you call that? Neglect now the base since they are equal. So getting only the exponent, we have x equals 2x minus 1. Okay, and then by transposition, we need to transpose all those terms with the x. Then we'll have x minus 2x equals negative 1. Then by combining like terms, we have negative x equals negative 1. Since both sides are negative, then divide both sides by negative 1. Therefore, the value of x is equal to 1. Okay, so if you want to check whether your answer is correct, you can substitute from the original exponential function. About 3 raised to 1 is 3. Then 3 raised to 2 times 1 is 2 minus 1 is 1. So 3 raised to 1. Okay, so in that sense, b sub 1 equals b sub 2. Therefore, x sub 1 equals x sub 2. Okay, let's have this one. So with our second example, as you can see, the exponential equations, the bases on each side of the equation are not yet into one-to-one property. 49 with a base of 7. So we know that 7 squared is equal to 49. So in doing that, we will arrive at its one-to-one property. Okay? So just putting down the bases, we have 2 equals x plus 1. Then by transposition of the constant, then we will get x equals 1. Okay? Very easy. Ano po? Okay. Second one, okay, we need to go identify which of the following are examples of exponential inequality. So you look first for the symbol of inequalities. Okay, does it contain a base, which is a constant, and an algebraic expression with x? Okay, so that's correct. B is yes, an example of an exponential inequalities. Which, what else about this one? Okay, yes. Okay, so we have letter D also, the letter E, but in the case of G, it's not. In the case of H, it's yes. So we have 4 examples of exponential inequalities. And how do we solve exponential inequalities? We need to determine first, or we need to know first, the different properties used in solving exponential inequalities. The first property is that if b is greater than 1. Okay, so of course, this is the basic definition of exponential function, that your b must not be equal to 1. Okay, it must be greater than 1. Then the exponential function y equals b raised to x is increasing for all x. Okay, increasing. Let's say, for example, the value of your x is 2, meaning all those values greater than 2 are the solution set. Okay, so this means that b raised to x is less than b raised to y if and only if x is less than y. Okay, so you will see here the x and the y notation natin. Okay, the second property, if the base is greater than 1, okay, the direction of the inequality is retained. Okay, so in the case of b is greater than 1, you need to see or to make sure that the base is greater than 1, or if that will be the case, no need for you to change the inequality symbol. Okay. Second case, if b is greater than 0 but less than 1, meaning to say your b are any fractions greater than 0 but less than 1. So the exponential function y equals b raised to x is decreasing for all x. This means that b raised to x is greater than b raised to y if and only if x is less than y. So look at the difference between the two. If b is greater than 1, we have this symbol. If b is greater than 0 but less than 1, then we have the greater than symbol. Okay. Third, if the base is less than 1, so the fractions nga, all you need to do is to reverse the inequality symbol. So this is another property of what you know before, that if in case the numerical coefficient of x is negative, diba? Dividing both sides by the negative numerical coefficient of that entails us to reverse the operation of the inequality symbol. Okay, so but this one automatic, that if your b is less than 1, you need to reverse your inequality symbol. Okay, let's try solving. Okay, so these are the rules. If the same real numbers is added to or subtracted from both sides of an inequality, the sense of the inequality is not changed. Okay, same real number. Like the APE, the addition property of equality before that you know. Okay, then if you will multiply or divide again the same number, the sense of the inequality again is not changed. But of course, if you will multiply or divide the same negative real number, you need to change the inequality symbol. Okay, let's have this one. Okay, so solving for x in 2 raised to x minus 2 greater than 8. Of course, the first thing that we need to do is to express 8 with a base of 2. Okay, and we know that 2 raised to the third power is equal to 8. So we will have this one. Then getting only the exponent, so we have x minus 2 is greater than 3. And knowing that b is greater than 1, okay, since your b here is 2, so this is under the first property. We do not need to change the inequality symbol. Okay, so solving for x, then we have x minus 2 is greater than 3. Therefore, by transposition, we have x is equal to 5. Okay, so what does it mean? It's increasing. Okay, the solution set of the exponential inequality is the set of all real numbers greater than 5. So greater than 5, meaning it's 6, 7, 8 up to infinity. Let's have another example. solving for x in 3 raised to x is less than 9 raised to x minus 2. So express 9 with the base of 2. So you'll have, yeah, okay, 3 raised to x is less than 3 raised to the second power, which is the value of 9 raised to x minus 2. Okay, so obviously the b is greater than 1, so we don't need to change. So solving for x, okay, so distribute the 2 here. Okay, then getting only by transposition, we have, okay, but now look at the numerical coefficient of x, okay? As we have said in the rules, if you will divide or multiply by a negative number, you need to change the symbol. Therefore, x here is greater than 4. Okay, so what does it mean? The solution set of the exponential inequality is the set of all real numbers greater than 4. Okay. Let's have another example. Solve for the values of x in 1 over 10 raised to x plus 5 is greater than or equal to 1 over 100 raised to 3x. So in this case, we need to express the 1 over 100 to a base of 1 over 10. Okay, so how do we do that? Okay, but then looking at the value of your b, this is under the second property that your b is under greater than 0 but less than 1. So meaning we need to reverse the direction. Okay, so reversing the direction, okay, and then at the same time distributing 2 kay 3x, then we will have, okay, so the x plus 5. So look at the symbol, from the original it's greater than or equal to, but since b is less than 1, so we have reversed it to less than or equal to. Okay, then distributing 2 with 3x, so we have 6x. Then by transposition, okay, so combining like terms, then dividing both sides by 5, therefore x is greater than or equal to 1. So what does it mean? So the solution set are all numbers from 1 up to infinity. Okay, so you can try solving for this, okay, for your practice exercises. And then for the second output for this week, learning task number 4, it's a performance task. So in the module that I have uploaded in the Google Classroom, I have included there the rubrics to be used in this performance task. Okay, so you need to read and understand the situation below, then answer the questions or perform the task that follow, okay, for the wise decision and friendship goal. So those are the only outputs, learning task number 3 and learning task number 4, the only outputs required in my subject for week number 5. Have a happy learning, math learning for week number 5. See you again next week. Thank you, everyone.